This video is about trigonometry and simple harmonic motion. The basic formula for simple harmonic motion is that x equals to a cosine omega t plus phi, where x stands for the position, a stands for the amplitude, omega stands for the angular velocity or the angular frequency, t stands for time, and phi stands for the phase constant, or how much the graph has been shifted from the initial position. The important component of the simple harmonic motion equation is that there is a cosine, where in order to graph the simple harmonic motion function, we need to understand the unit circle first. The shifts in the equation are associated with the movement along the unit circle, which will be mentioned in a minute. First, let's see what a means in the simple harmonic motion function. A stands for the amplitude, where the amplitude is defined as the maximum distance from the equilibrium position. So if we have a cosine wave that has a maximum value of 1 and a minimum value of -1, we know that the amplitude is 1, hence a from the equation would equal to 1. In contrast, if we have a cosine wave that has a maximum value of 1/2 and a minimum value of -1/2, we know that the amplitude is 1/2 and hence a from the equation would equal to 1/2. So this shows that the changes in a are proportional to the changes in amplitude. Now let's see how changes in the phi, or the phase constant, would change the shift of the simple harmonic motion equation. Let's first consider when the phase constant phi equals to 0. Where would the cosine wave start at time equals to 0? Would it start at 1? Would it start at 0? Would it start at -1? Well, in order to answer this question, we need to look at the unit circle on the right. For the cosine graph, we want to look at the x value. When time equals to 0, and when the unit circle has an angle of 0, we see that the value of x on the unit circle equals to 1. So this is how we know that on the graph on the left, that the graph would start with 1. Now let's say when time equals to pi over 2, or 90 degrees on the unit circle. At 90 degrees of the unit circle going counterclockwise, we know that at 90 degrees the coordinate would be 0, 1, which means that if we look at the x value, that's when x equals to 0. So this is how we know that the cosine graph would have a position of 0 at time pi over 2. We can continue to draw the wave and at coordinate -1, 0, or at an angle 180 degrees, or at pi degrees, the value of x equals to -1, so we know that at 180 degrees or pi radians, the position would equal to -1. As we continue to do this process, we can complete the cycle, and once we complete the cycle, the patterns will repeat. The important takeaway here is that for this cosine graph, when the phase constant equals to 0, then the cosine graph would start at 1 because you'll start at a 0 angle on the unit circle on the right. Now let's see when the phase constant equals to 90 degrees. This means that on the unit circle, we want to start at 90 degrees or pi over 2 instead of 0 degrees. We still want to look at the x value, but at pi over 2 degrees, that will be the coordinate 0, 1 on the unit circle, which means we have 0 for the x value. So at time equals to 0, we would also start with a position of 0. We continue to follow the unit circle, going with 180 degrees next. We see that as angle goes from 90 degrees to 180 degrees, the x value decreases from 0 to -1, which we also see that on the position graph on the left. But once the angle hits 180 degrees, that's the minimum value it can get. It will start to increase until it hits that 270 degrees, and that's when the x value would come back again at 0. We can also say that the phase constant shifts the graph to the left when pi over 2 is added, and the phase constant would shift the graph to the right when it is subtracted. So if we have a cosine of omega t plus pi over 2, that will shift the graph to the left. And if we have cosine of omega t minus pi over 2, that will shift the graph to the right. So this was a brief lecture on the simple harmonic motion and the unit circle. I hope you enjoyed the video.